Hi, welcome back to another video about LTSpice. So last time I already published a video about param part 1. So this is another video about param part 2. Last time we used param together with step simulation command, but now we will know more about the benefit of using param. For example, here I have a circuit containing 3 different low-pass filter. Let's say I want to have the first low-pass filter with the resistance. You could say the resistance R1, R2, and R3. I want to set them with a fixed value and they have the same value. If you do manually, you have to right-click on each capacitor, and then you edit the value. Right-click and then you edit a value. It's very troublesome. param will somehow make those steps less troublesome and faster and more efficient. Okay, first I want to set the different values for the capacitance because I want to have 3 different types of low-pass filter. So let's say, for example, the C1, I will have a fixed value of 1 microfarad. The capacitance of the C2, 2 microfarad. And the capacitance of C3, 3 microfarad. Okay, and as I say, I want to have the 3 resistors R1, R2, and R3 have the same value and they are fixed. And I'm going to use param to make the steps more easier. And how can we do that? First, we need to set the R here as a parameter. In the previous video, what do? Control right click on the component and we have this window, and in this window at the value here we need to have the curly bracket which tells the LTSpice software that what is inside the curly bracket is a parameter name. So resistor is a parameter, and because I want the R2 also has the same value with the R1, so that's why here the name of the parameter should be the same with the name of the parameter in R1. And also for R3, control right click on R3, this one, the same value with R1, so of course the name of the parameter should be the same. Same name of the parameter indicate the same value. Resistor. Okay, now we have the parameter of resistor, but we haven't set the value for the resistor. You can do it in 2 ways. The first way is to right click in the schematic, choose draft and choose spice directive. In the blank box you type .param and you type the name of the parameter resistor and then the value of the resistor parameter, let's say 1 kilo ohm. Okay, we got it here. Or you can put it like here, there's an option .op, which is the spice directive. It will show you the same blank box where you can type in param resistor and then 1 kilo ohm. They are the same, so let's delete one of them. You choose the scissor to delete. Okay, now we delete one of them. Let's set the input signal. The input signal will be a pulse, or maybe let's say a swell wave based on pulse. If you want to know what are these parameters are for, please, I already put the reference video that I made before in the comment section of this video. You could refer to that to see more detail about what are these parameters for. But here I will just set a value v initial 0, v on 1, t delay at 1 2, rise time. Let's set it to be very small, so it could be considered as an ideal rise time and ideal fall time compared to the on time, which will be much bigger, which is 4 milliseconds. T period, time, the period of the sway wave, I would say 8 milliseconds. And yes, now we got the input signal. Okay, let's see what else do we need. We need the simulation. Press run and then choose the simulation. To demonstrate the simulation, I would choose the transient simulation to demonstrate. In this example, I want to have 3 pulses, a sway wave with 3 pulses. Then here, 1 pulse or 1 period of a sway wave is 8 milliseconds. I want to see 3 of them, so 3 times 8 is 24 milliseconds. Okay, now let's measure. This is our first output, and let's see the second output. This is the second, the blue curve is the second output of the second low pass filter, and then let's see the third one. The red line is the third output of the third low pass filter. Easy, right? So now let's see the power of using parameter param. Here I want to change the value of the resistor to another one, like 2 kilo ohm. If you didn't use parameter, you will have to manually edit the value of the resistor here. You have to manually edit the value of the resistor here for at least 3 of them, which is very troublesome. But with the .param, you just have to right click, move your mouse to the .param text, and then right click. Here you can edit the value to 2 kilo ohm. Okay, now all of the resistor here, R1, R2, and R3, all have the value of 2 kilo ohm. Let's run the simulator. You could see the totally different when I change it to 3 kilo ohm, right? Now if I change it to change it to 2 kilo ohm, totally different and very fast. And I want to see, let's say 3 kilo ohm instead. Press OK, and then I press run simulator. You could see very different with the 3 kilo ohm for these parameters, for these resistors. So as you could see, .param is very efficient in order to change the value of many components which have the same value. You just have to change one and all of them will be changed accordingly. So that's the power of using .param, and I hope that it's also helpful in a way. If you find the video is helpful, please give us a like, or you can subscribe to my channel. Thank you so much for watching. See you in another video. Goodbye.